Hi, welcome to WISE Guys. Uniform circular motion, practice question 3. In this video, I would like to show you when normal force acting as the centripetal force. For example, a car given is mass is 2,500 kilogram, and the speed velocity equals 36 kilometer per hour, and there are 3 different situations when the car is driving on the flat road, and the second situation is drive on the road is this way. And third situation, drive on the road this way. 3 different situations. So this is a horizontal flat road. So this situation, what is we looking for? Normal force. Normal force in 3 different situations. And this situation, because it's flat road, so the gravity and the normal force, they are same. So that situation we can say, because Fg equals mg and equals to 25 kilogram, which is 2.5 times 10 to the 3 exponent kilogram, multiply 9.8 meter per second square. We got Fg, we got 2.45 times 10 to the 4 Newton. And because it's flat road, that's why normal force equal to gravity, which is 2.45 times 10 to the 4 exponent Newton. In second situation, the car is driving on the circular shape, which is looks like concave up, right? So down. So the radius we give in this situation, if the radius is 20 meters. So what is the normal force in this situation? Because we know this is when you're driving, at this situation at the bottom, the free body diagram is gravity and the normal force. Because this is the circle shape, that's what the center on the top. So that's why this situation, the centripetal force is the net force of normal force and the gravity. So we can write centripetal force is the normal force subtract the gravity, and which equals to mv squared over r. In this situation, we say at the bottom of the bridge, or on the bottom of this shaped road, and the velocity or the speed is at this moment, only talking about this moment, right? So this is we label as bottom v. So then we can calculate the normal force. So normal force equals to move Fg to the other side. Fg equal, because Fg equals mg, so we can write mg plus m times v square over r, which we can write normal force equals, we pull the m out, can say g plus v square over r, and we can plug number in. This is 2.45 times 10 to the 4 exponent, no, sorry, because we need to plug this one. So, okay, so the normal force equals m, which is 2.5 times 10 to the 3 kilogram, multiply 9.8 plus the v square is 36 kilometer per hour. Because we know 36 kilometer per hour, we can convert to meter per second just using divided by 3.6. Yeah, you convert kilometer per hour to meter per second, you just divide 3.6. And this is equals 10 meter per second. To convert kilometer per hour to meter per second, we already have video on the practice question 1. So you can look at this one to see how to convert. Here I just using divide the 3.6. 10 meter per second square divide the r, which is 20 meter. Then we got the normal force, where the answer is 3.7 times 10 to the 4 Newton. So you can see, I drive on the road like this condition, this shape, the normal force is greater than the gravity. The reason is normal force acting as a part of centripetal force. The net force of normal force and the gravity as the centripetal force. So the normal force has to be greater than the gravity so that they keep the car going this way. This normal force is at the bottom. So what about the third situation? The third situation, let's go to the other page. The third situation, the car, the drive on the shape is, this looks like concave down, the circle. So the center is at the bottom, at this side. So free body diagram, we have Fg, which is gravity, the normal force, still have normal force. And this situation, at this moment, the V is at the top, at the circle. That's why we say, now the V still say is 10 meter per second, which is 36 kilometer per hour. And this situation, how to apply to this formula. So as we know, the centripetal force is the net force, the direction point to the center of the circle. That's why the direction point to the center of the circle, the gravity, using gravity, subtract normal force. Because this is the net force, direction of net force, which is centripetal force, has to be point to the bottom. That's why this is become positive, this is become negative. So equals mv at the top for r. So we can move Fg to the other side and multiply -1, then we have normal force equals Fg subtract mv squared over r. Then we can calculate the normal force. We write mg minus m v squared over r, and we can pull the common factor m. We have g minus v squared over r, and so normal force equals, we plug number in, the gravity is 2500, so which is 2.5 times 10 to the 3 exponent kilogram, multiply 9.8 minus, if we still using 10 meter per second, is 10 square divided radius is 20, so we got normal force, we got 1.2 times 10 to the 4 exponent Newton. So compare these two situations, or the other two situations. We got, when driving on the flat road, the normal force equal gravity, 2.45 times 10 to the 4 exponent Newton. When driving on the circle shaped road, which is concave up, so at the bottom, the normal force is 3.7 times 10 to the 4 exponent. And while driving on this shape, which is concave down, the bridge or the road looks like this way, and the normal force gets smallest, which is 1.2 times 10 to the 4 exponent normal force. So this video is just to give you an idea, and the normal force also can be the centripetal force. This is the one. The second one, when you write centripetal force equals mv squared over r, make sure the centripetal force is the net force, and also is the direction it points to the center. Direction point to the center at this situation, Fg minus normal force. At the previous situation, because center is up, that's why you use normal force minus Fg. If you understand these three, it's okay, no problem. Okay, this is presented by Wise Guys. Thank you.